Good morning. This is Ms. Billerbeck, and we're going to talk about 12.4 spheres. So a sphere is a solid where all the points on the surface are a constant distance from a fixed point. Wow, that's a lot of verbiage, huh? So the constant distance is the radius. So the fixed point is the center. So if we substitute that into this, a sphere is a solid where all the points on its surface are a constant radius or a fixed radius from the center of the shape or solid. So here we have a sphere, and we have the fixed center and a radius. And so it'll circulate around here, and that radius will be the same no matter where it is in that solid. And then the diameter of a sphere measures from one side of the sphere to the other side. So a line segment, this line segment, joining 2 points on a sphere, here and here, and passing through the center there, is a diameter. So that is the technical term for the diameter of a sphere. All right, let's look at some formula. Formulae is plural for formula. So spherical formula, spherical is just the adjective of sphere. Okay, the spherical formulae, our volume of a sphere is 4/3 pi r cubed. So that's derived from subtracting a cone from a hemisphere, and then what you have left you double. So that's how that came about. Okay, so when we find the surface area of a sphere, it is 4 pi r squared, which is very different from 4/3 pi r cubed for the volume of a sphere. So remember, volume, three-dimensional units, so you should have a three-dimensional radius. So 4/3 pi r cubed is the volume, 4 pi r squared is the surface area, because area is square units. Now Archimedes proved that the surface area was equal to the curved surface of a cylinder. So if I have a cylinder as such, but the height of the cylinder is equal to 2 radii. Okay, radii is plural for radius. So 2 radius. So if you think about it, we would have a radius that goes up to here, and a radius that goes down to here. So technically we would have a little line like that going around like that. Okay, so this would be R, and this would be R as well. Okay, so 2 radii is the height of the cylinder, and then the radius of the cylinder would be here, and then of course the radius is over there. So if we look at the surface area formula for a cylinder, it would be 2 pi r h, but if h is 2r, then we multiply it, we get 4 pi r squared, which is our formula that we use for the surface area of a sphere. So there you have it. Okay, so now what we're going to do is a few examples. So find the ratio of the volume of a sphere with a radius of 6 centimeters to the volume of a cone with a radius of 6 centimeters and a height of 12. Well, a picture is worth 1,000 words, so we draw a picture. So we have our sphere. Okay, and then our radius of our sphere is 6 centimeters. Okay, then we have a cone. So we'll put the cone over here. This cone is tall. Okay, so we have our radius here, And the radius of the cone is also 6 centimeters, so that we'll say R is that, and we will put R equals 6 centimeters since it's a little tight. And let's just pretend that I made this a right cone instead of a slightly Tower of Pisa cone. Okay, Tower of Pisa is the leaning Tower of Pisa, in case you don't know. So 12 centimeters is the height. Okay, so it wants us now to compare the volume of the cone with the ratio of the volume of the sphere with the volume of the cone. Okay, so the volume of the sphere, again, is 4/3 pi r cubed. So we have 4/3 pi, and we're going to make that 6 cubed. Now we should know that the cube units look like this when we expand it out. That'd be 6 times 6 times 6. Okay, so we can also cancel one of these 3's out and make that a 2, which makes that a whole lot easier. So now we have 4 pi, and 2 times 6 is 12. 12 times 6 is 72. So remember, if you reduce fast or early, it really helps with the problem solving. So now we just have to figure out what 4 times 72 is. So, oops, this is the volume of the sphere, not a volume of a 3. Okay, so volume of a sphere then is, so 4 times 2 is 8. 4 times 7 is 28. So we have 228 pi centimeters cubed because it's volume. Okay, so now we have to find the volume of the cone. So the volume of a cone is 1/3 pi r squared h. So that gives us the volume of a cone. Okay, so then we have 1/3 pi. R is still the 6 squared, and then h is 12. Okay, so we can take one of these 3's out of here and take one of those 3's out of that. So then we end up with pi, and 6 squared is 36 times 4. So our volume of our cone ends up 4 times 6 is 24, area 2, and we have 4 times 3 is 12, plus 2 is 144 pi centimeters cubed. So now we need to go back to the directions, and it says find the ratio of the volume of the sphere with the radius of 6 centimeters to the volume of a cone. So we are looking for this volume sphere to volume cone. Okay, so now we have our answers. So let's put it over here where we have a little more working room. So we have 228 pi to 144 pi. Now, I happen to know that 144, if I divide by 144 pi on both sides, oh, wait, I can't do 144 because that was, oh, I wrote this down wrong. Now I can, huh? Be careful about transferring information. Make sure you do it right. So 144 pi here. So that cancels out. So 144 pi over 144 pi is just 1. And if the pi's cancel out and this ends up being 2, and the pi's cancel. We have a 2-to-1 relationship between the volume of a sphere to the volume of a cone. Isn't that interesting? Okay, so there we have it. Now let's try another example. All right, so we have a hollow crystal ball, has an external radius of 5 centimeters and a thickness of crystals 1 centimeter. Find the volume of the crystal in the ball. So again, a picture is worth 1,000 words. So we are drawing our crystal ball, and we have an inside diameter like this, or inside surface like this. Okay. And I'm just going to do a cross section. So a cross section is what we do in the engineering world. Okay, so I'm going to make this a decorative cross section. Okay, so it's like it's called an annulus in the engineering world. Okay, so we've got a little annulus going. So if I look at the radius, the inside thickness here is 4 centimeters. And then the thickness here is 5 centimeters. Okay, so now I'm going to create a strategy. So my strategy is I'm finding the volume of the crystal, so I only want to know this red part of the sphere. Okay, so I am going to say volume outer minus volume inner equals volume crystal. So that's what we want to find. And this in here is the volume of the crystal, which is what we're trying to find. Okay, so we're dealing with a sphere, so all formulas have 4/3 pi. So we have a volume of a sphere is 4/3 pi, and then we have r cubed. So when we look at that, we have 4/3 pi, and the outer one was 5 cubed. And then we're going to subtract 4/3 pi and the inner one, this inner diameter to the 1. So you didn't follow, this little part here is 1 centimeter. Okay, so 1 centimeter plus 4 is 5. Okay, so that's where I got the 4 centimeters. So this one's going to be 4 centimeters cubed, but I can just say, hey, this looks like this. If I go like that and I say 5 cubed minus 4 cubed, I'll have my answer really quick. All right, so now we have to figure out, well, what is 5 cubed and 4 cubed? So we have volume of the crystal, then is going to be 4/3 pi, and then we have 5 cubed is 5 times 5 is 25. 5 quarters is $1.25, so this is 125. 4 cubed, 4 times 4 is 16. 16 times 4 is 64. All right, so again, we crunch the data some more. So if you want, you can go like this to make it easy. Then when we subtract, we have 1 here, and then when we borrow, we get 61. So this is 61 right there. Okay, 61 is not an easy number to work with, unfortunately. All right, so let's do it anyway. So we are going to multiply 4 times 61, so volume of the crystal, and then that's 4 times 1 is 4, and then we have 24, and then we are going to divide by 3 still, and we have pi. So when we divide by 3, and we can do it using long division, 2, 4, 4 divided by 3, we have 8 here. 8 times 3 is 24. And we subtract, we get 0. We drop the 4 down, and we have 1. And we put in 3 here, we subtract, and we have 1. So we have 81 1/3. Or, but because we're using pi, we would probably want to use the decimal version. So, okay, so there's a point here, and so that's 3, and then this is going to be a repeating 3. So it's just going to keep going because 1/3 is equal to 0.3333. So we're going to approximate that to 81.3 times pi. Okay, if we want to go a step further, we can go and multiply pi out. So let's do that to practice some of our multiplying. Okay, so pi equals 3.14. It doesn't exactly equal 3.14 because pi doesn't ever end. So many times we approximate it to 3.14. So this becomes 81.3 times 3.14. Now we're going to have some error because we rounded this one and we rounded that one. So there'll be error. Okay, so 81.3 times 3.14. So this line we're doing 4 times 813. So we have 12,532. This line is 10 times 813. So we have 0, and then we have 318. This line, hopefully I will have room, is 300 times 8113. So we have 0, 0, and then 3 times 3 is 9, 324. So when we multiply, we get, or add all that, the columns 2, 8, 12, then that's 15, 5, and 2. And we move the decimal place 1, 2, 3. So it's going to go right there. So our volume of our crystal approximates to 255 point. And since we approximated here, let's just round this one to, this is 5 or more. We're going to raise the score to this, and we're going to put centimeters cubed. All right, let's try the next example. All right, so a table tennis ball has a diameter of 4 centimeters. Find its surface area and volume. Okay, so we have a table tennis ball. Okay, we have to be careful with this one because they're talking diameter. Okay, so we've got something going on like this. And they're saying this diameter right here is 4 centimeters. But we want the radius. So the radius is half the diameter. So that'd be half 4 centimeters, which gives us 2 centimeters. Okay, so that we needed to do at the beginning, otherwise we would have a very painful time of it. So find its surface area and volume. Okay, so the surface area of a cube, I'm sorry, of a sphere is 4 pi r squared. So we have 4 pi and then 2 squared. So 2 squared is 4. So 4 pi times 4, which is 16 pi. And we're dealing with centimeters, so it's centimeters squared. So our surface area is 16 pi centimeters squared. The volume then would be 4/3 pi r cubed, because volume is three-dimensional. So then we write 4/3 pi 2 cubed, which is 2 times 2 times 2. So we have 4 times, thirds pi times 8. Little parentheses around that one too. So that ends up 4 times 8 is 32 over 3 pi. Okay, so well, let's try to figure out what 32 over 3 is. We divide 32 by 3, and that gets us, I'm going to do that one in my head, so that's 10 and 2/3, and 2/3 is 6, 7. So let's just round that to 10.7 pi centimeters cubed. Okay, so I just took 32 here, divided it by 3, had 1, dropped the 2 down, 0, and then I had 0, and if I drop this down, wait a second, wait, there's a 2 there, excuse-moi, 2, okay, so there's 0 in that one. So when I subtract, I have 2, but then when I drop this down, I get 6, because 18 works, but then I just keep getting 2. So it's a repeater again. So it just goes like that for 2/3. So if I'm rounding to this, it's 5 or more, raise the score. So that's where I got the 7, by the way. Okay. So anyway, so that is the volume of the sphere and the surface area. So there you go. All right, next example. So the surface area of a sphere is equal to the total surface area of a cube with sides 10 centimeters. Okay, so we have the surface area of a sphere, 4 pi r squared, is somehow going to be equal to the volume of a cube, which is a volume length times width times height, but they're all 10. So that's 10 times 10 times 10, which is 1,000. Okay, so we need to find that radius now. All right, so the volume of so now we can divide, we have 4 pi r squared equals 1,000. So what we need to do, first we'll divide by 4, because I forgot to do that last time when I did a tough one with pi. So that cancels, so we have pi r squared equals 250. Now we have a little smaller number, and now let's divide by pi. Okay, so we're going to have r squared over here once I figure it out. So let's use the dry erase calculator. So we have 250 And that's going to be divided by 3.14. Okay, so top dog goes in the house. So 3.14. All right, so then move this decimal over 1, 2. So it goes right here. So we ask how many 300s are in 250, 0. Then how many 300s are in 2500? Or how many 3s are in 25? And that's 8. So 8 times 4 is 32. Carry a 3. 8 times 1 is 8 plus 3 is 11. Then 25. Ah, look at that. We just missed it. We got to go with 7. This is bigger than that, so we can't subtract. That's a bummer. So 7. Okay, so 7 times 4 is 28. 7 times 1 is 7 plus 2 is 9. And then 7 times 3 is 21. So when we subtract, we are going to have to borrow and give a 10 there, but we have to borrow again and give another 10 there. So we have 2. That's going to be 0 and 3. So look at that. We just missed it. Oh, it's painful. Okay, so then we drop a 0 down. So since we just missed it, this is probably going to be a 9. So let's think about that. Is it 8 or 9? Yes, it's going to be a 9. So 9 times 4 is 36. Carry 3. Then we have 12. And then 3 times 9 is 27 plus 1 is 28. And we did it. So when we subtract that, or we have to, oh, this is going to be a lot of borrowing. We have 4, and then we have to borrow way over here. I'm going to make that a 9 because things are getting messy. Then we have 9 and 1. So we still did great. This is less than that. If we want to figure out what the decimal is here, let's see, is that going to be 4 or less? Let's see. So how many 3s are in 19? Well, there's about 6. So let's see if the 6 works. So 6 times 4 is 24. Carry a 2. And then we have 8 and 18. So it did. So we end up borrowing again. 6, borrowing again. 5, 56. So that was pretty close. So 6 is 5 or more, raise the score. So we're going to approximate. I guess we can't really approximate. So let's just go one more and say that's a 1. Okay, so we have to get the square root because this is 79.61 because there's about one of the 314s in 560. So that's why I put 1 right there. Okay, so r equals the square root of r squared. So I'm going to take the square root of 79.61. And just for schnickers, I am going to estimate. So this is very close to 81, which we know the square root of 81 is 9. So I am going to say this approximates to 88.9 centimeters. Okay, so let's go check that. Pull out the handy dandy graphing calculator and see how the guess went. Okay, so let's clear it. So I have, first let's do 250 divided by pi. Okay, so that, ooh, I missed it. Oh, that was 79.57. I made a mistake. Well, good. Oh, that's because I'm dividing by the real. See how I was a little off because I was dividing by an approximated an approximate pi, just 3.14. This one's going to be accurate. So 79.6 would have been great. Okay, so now I'm going to take a square root of that and see what it is. 8.9, look at that, guessing pretty well. Okay, so that's how you approximate a square root, by the way. All right, so now let's do a creative problem here. So I have a conical glass stopper with a spherical end. So I want to know what the volume is of this stopper and what the total surface area is. Okay, so anyway, we have a hemisphere, not a whole sphere. So the volume of a sphere, again, is 4/3 pi r cubed. But we're only dealing with half. So we're going to do half the volume here. Okay, which would make that a 2. So this ends up 2/3 pi r cubed for a hemisphere. So that is hemisphere is half of a sphere. Okay, so we have to get that, which will be simple because they gave us an r. So then the volume of the cone is 1/3 pi r squared h. Okay, so they didn't give us an h, they gave us 7, which 7 includes this 3 if you weren't being careful. So that means this part right here is 4 centimeters right here. So our height is 4 centimeters for a cone. So the height of the cone is 4 centimeters. Okay, so now we can figure out the volume of that plus this. So this is going to be volume at the hemisphere. So volume total will be the volume of the hemisphere. Oh, look at me and my little brain working so weirdly. Okay, volume of the hemisphere plus volume of the cone equals, so now let's put it together. So we have 2/3 pi, and our radius is 3 cubed, plus, and then the cone is 1/3 pi. We have the same radius, r squared, and the height is 4. Okay, when we're dividing by 3, and let's reduce some of this. Well, let's expand it first so it's easier for you to see how I'm reducing it. So it's 2/3 pi, and 3 cubed is 3 times 3 is 9, times 3 is 27, plus 1/3 pi, and then 3 times 3 is 9, times 4. So we can take 1 3 out of here and make that a 9, 1 3 out of here and make that a 3. So we have 2 times 9 is 18 pi, plus, and then 3 times 4 is 12 pi. So our volume total of this beautiful glass stopper ends up being 30 pi centimeters cubed. Okay, so now we have to figure out the surface area. So surface area for a sphere, and let me get a new board. Okay, let's use this board. Get one off. Okay, so the surface area, when we look at that, we've got the surface area of a cone is 4 pi r squared, but we're only doing half of it. So we have 2 pi r squared, because if we reduce that, that's a 2. Okay, so this is surface area of a hemisphere. Okay, so the surface area of this is only the lateral surface area because the circular base is covered by the hemisphere, so we do not count the base of the cone when we're doing this. Okay, so we have the surface area of the lateral surface area. So let's call that lateral area, L, of the cone is pi RL. L is right here. Oh, do we know what L is? No, we don't. We only know what R is, and we know what H is, because we needed that to know volume, but we don't know L. But when we look at this, we have a 3, 4, and if we know our Pythagorean triples, we know L is 5. But just in case you didn't know that, let's find it out. So we look at this area of the cone. Okay, so we have a right angle here. We have a 3, 4, and we need that L. So now we have L. We can use the Pythagorean theorem, a squared plus b squared equals c squared, or c equals square root of a squared plus b squared, which we are looking at L because this is c. So L equals the square root of 3 squared plus 4 squared. So that's 9 plus 16, which is the square root of 25, which is 5. So if we knew our Pythagorean triple, we would be going, happy days, we know that one right away. All right, so let's go back to surface area now of our hemisphere, because we have everything we need to know for that. So 2 times pi, and then r is 3 squared, so 3 squared is 9, 2 times 9 is 18 pi, and this is surface area, so we're dealing with centimeters squared. Surface, we're not doing total surface area, we're doing the lateral of the cone, is pi times same radius, 3, but the L is 5. So that gives me 15 pi centimeters squared. So then the total, we add it up. So we have pi, and then 13, carry 1, 33 pi centimeters squared for total surface area of the stopper. So again, you break it up into parts. We have the cone surface area and then the hemisphere surface area. Okay, so the hemisphere surface area was the 18 pi centimeters squared, and then the conical surface area down here, just this part here, not the base. We were only concerned with the outside here, not the base at all, because the base was hidden by the conical, or hidden by the hemisphere. This kind of topped off the base of the cone, so it was never exposed, so it didn't have surface area. It was just part of the volume. All right, there you go. That's what we have for spheres. I hope you have a wonderful day. Bye-bye.